In this example, we will explore the graph of y equals secant theta. In part A, draw y equals secant theta. Bring up the unit circle for secant theta. We need to create a grid so we can draw the graph of y equals secant theta. We have a line representing 2 root 3 over 3. We have another line representing root 2. By symmetry, we also have lines at negative 2 root 3 over 3 and negative root 2. Draw the points from the first quadrant. Draw the points from the second quadrant. Draw the points from the third quadrant. And draw the points from the fourth quadrant. Draw the graph and asymptotes. If we go around the unit circle clockwise, we can draw the left side of the graph. In part B, state the period of y equals secant theta. Bring up the graph of y equals secant theta. The period is 2 pi. In part C, state the domain and range. Bring up the graph of y equals secant theta. The graph exists for all real numbers, with the exception of the asymptotes, where secant theta is undefined. The domain is theta belongs to the set of real numbers, with the restriction that theta cannot equal pi over 2 plus n pi, where n belongs to the set of integers. The graph does not exist between y values of negative 1 and 1. The graph exists when y is less than or equal to negative 1 or y is greater than or equal to 1. This is the range. In part D, write the general equation of the asymptotes. Bring up the graph in the domain. The restriction of the domain for y equals secant theta becomes the equation of the asymptotes. The asymptotes occur at theta equals pi over 2 plus n pi, where n belongs to the set of integers. Now we'll move on to part E. Given the graph of f of theta equals cos theta, draw y equals 1 over f of theta. Drawing the reciprocal graph of y equals cos theta is a quick way to create the graph of y equals secant theta. In step 1, draw asymptotes at the x-intercepts. In step 2, points where y equals negative 1 or positive 1 are invariant. This means that they occupy the same position in both graphs. Finally, in step 3, fill in the secant shape.